All right, so number 3 in your assignment, this is what it looks like. Remember, we're doing the ICE charts. So ICE stands for initial concentrations, C stands for change in concentrations, and E stands for equilibrium concentrations. And so this ICE chart method is a good way to help you organize things. Now, this one is not a typical question, but you can still use an ICE chart. It says how many moles of HCl are needed, so that is initially, okay, in a 1 liter flask to produce 0.6 moles of chlorine at equilibrium. So there's your E. So you're actually given an equilibrium concentration and you're asked to work backwards. Okay? So we can still do our ICE charts. We have a balanced equation up here. So you can still do your ICE, ICE. And make a little chart here. And you want to put your 2HCl right here, and your H2 and your Cl2. Okay. You know what? I always put the 2 in the chart. Yeah, because that helps me remember how things happen with the change. Okay. So yeah, I always put the molar ratio here. The question was, do you have to put that there? I always do, because then I can see that this is a 2-to-1 ratio between these two. Right? If you don't put that there, you might not look back up to the original equation, and then you might, kind of forget to do that. So, yeah, that's just what I do there. All right, so what are we given? 0.6 moles in 1 liter. So remember, we have to have concentrations. So 0.600 moles in 1 liter, right? So what's that for a concentration? Well, 0.600 molar, right? It's in 1 liter, so it's the same concentration. All right, and that is chlorine at equilibrium. So you're going to put that right here, 0.600 molar. Now, I don't often put the molars in the chart. You understand that everything has concentration, so you can do this if you want to remind yourself as well, but you don't have to. It's all molar. All right, so we started with some unknown quantity of HCl to produce this concentration of chlorine. And I guess I should mention, I didn't put that down, but the KEQ, which obviously we'll need, is 2.00 times 10 to the negative 2. Oh yeah, I put it up here, sorry. I do see it now. Okay, so the KEQ, yeah, that's going to be important as well. All right, so what do we know? What about, so what, you guys had a shot at this, okay? What did you do next here? What are some things, how can we start filling out this chart?
Logic would tell you that HCl and hydrogen are equal something.
Okay, so if if hydrogen and chlorine are both being produced in this equation at a 1-to-1 ratio, you're saying that logic would say that this probably should be 0.6 as well. That's exactly right. That would be 0.6 as well. Remember, they're being produced at the exact same rate, and at equilibrium, they should have the exact same concentration, because it's a 1-to-1 ratio. All right? Okay, good, good. So what's next? What else can we do? How can we use this chart to solve, for what we're looking for here? Anybody? So HCl is 2 of these. Well, here's the thing. Okay, I'm glad you said that. HCl, it is a 2-to-1 ratio, okay, but you have to consider this, the concentrations here are, we only start with HCl. How many moles of HCl needed? Dot. So this is going up in concentration, okay? This is going down. So at equilibrium, this is not going to be 2 times 0.6. And I'm glad you said that, because that's something that you would immediately say, oh, wow, 1-to-2 ratio. Let's just put 1.2 here. No, you can't do that, because you're assuming that all of this is starting at 0, which doesn't quite make sense, right? We have to start with some concentration of HCl. So, not 1.20, but thanks for the offer. Okay. What did I say here? What did we start with? HCl. So how much H2 and Cl2 do we have at the beginning? Yeah, 0. Okay. So that's something that you do know. Now, actually, if you look at the initial concentration of 0 and the end concentration, or the equilibrium concentration of 0.6, what was the change here from 0 to 0.6? It was, if I start off with 0 and I ended with 0.6 molar, what was the change? It went up by, yes, and this is why this question is a little bit strange, because you're used to putting variables here, right? Like, what was the change? We don't know. Well, we aren't normally given equilibrium concentrations either. So this is 0, and this is going up by 0.6. Okay. Any other offerings for what's next? Is this looking at all like your charts, or?
The minus 0.6 times 2.
Okay, all right. So the molar ratio here now is where you look at in the change row. That's where you use the molar ratio. So yes, if this is going to go up by 0.6, the HCl is going to go down. Remember this up here? It's going to go down by 2 times 0.6. So that's where you get this right here. All right. So there's the molar ratio in the change row. Okay. So what do I put right here in this spot right here? How much did I start with? This is your cue to say, I don't know. How much do we start with? I don't know. Okay, unknown. Unknown, okay? All right, is it just early, or is it just early in the morning? You're all looking very, very stunned. Okay, all right. So how many moles, look at what the question's asking, how many moles of HCl are needed at the beginning? So what we don't know is how many moles of HCl. So let's say that this is going to be X right here, okay? Because we don't know how much at the beginning. Most of the questions that we have are, we don't know what the equilibrium concentrations are, right? But this time, the equilibrium concentrations are given, and the initial concentrations are unknown. Everybody understand that? Yep. Yeah. Yeah, we're not done yet, though. Yeah, we're not done yet. We're going to plug things into an equation. Yeah, but we aren't quite done yet. Okay? So, what is the last space to be filled here? Right, and of course, that's what we do for equilibrium row, is we say x minus 1.20. And you fill in that last spot there. Okay? Okay, questions with that? Did any of you have this chart filled out just like this on your own? No, not quite? Okay. How many of you attempted this question all the way through to the end? Okay. All right. Not very many of you. Okay, well, I was hoping that you would have tried that. Anyways, so what do I do now? What do we do now? Okay, yeah, we need to use the equilibrium equation now, right? The equilibrium expression. So what's the KEQ? Yes, this is the value, but what is the expression? Okay, let's just do the expression here first, okay? H2 times I2, e to the power of 1. Thank you. I'm thinking of another question. You're right. Cl2, glad you guys noticed that. Cl2, okay, divided by concentration of HCl squared. Yes, because of the 2 there. Okay, so that's your KEQ expression, right? Now we start filling in some values. Okay? So I want you guys to now finish this on your own. Okay? You should be able, that's the tough part. So you go ahead and finish that on your own. And I'll finish it here while the screen is frozen up there, and then I'll let you know what I've done at the end. Alright, so here's the rest of the problem here. It should be up on the board there for you now. from the KQ expression, you fill in all your values, right? You have both of these are squared up here on the right side, so you take the square root of both sides. You multiply both sides by x minus 1.20, and you get this. You only have x in one spot, so it's pretty easy to isolate x, and you should get this. And remember, this x is our initial concentration of HCl. That's what we let x equal in our chart and in our equation. So when you get x, you always have to make sure that you go back and say, okay, what was x? All right, x was my concentration initially for HCl. So there you go, concentration of HCl, 5.443 molar, and they're looking for the number of moles, right? How many moles? So it's not a concentration, it's a straight number of moles, but in this case it's in a 1 liter flask. So it's the same as the concentration. But that's what you should end up with here for your answer for this question. Now, if the question asked for how many moles of HCl were left at equilibrium, then you could do that as well pretty easily by looking at the equilibrium expression for HCl, right? And then you have 5.443 minus 1.20, right? So you have 4.243. You just plug x in, okay? So that's an example of a question where you have to work backwards. Okay? That's a little bit different than most of them.